Greetings folks and welcome to the Electromaker Show. This is your roundup of all things maker and embedded and lovely. Now we had another little break just because things have been incredibly busy at my end. It's also been very hot here as well as pretty much everywhere else. Hopefully the nice Nvidia thingy that I have working with my microphone will be cutting out the background sound of the fan in the window, without which there would be absolutely no show. But yes, we have a packed show this week as well as announcing the winner of our Audio DK contest we started a few weeks ago now. So let's get on with the show. We're going to start the show by talking about Maker Faire Rome. Now, if you were hoping to attend Maker Faire Rome, the tickets still haven't been announced, but that will be happening soon. However, the people who are exhibiting at Maker Faire Rome have now been chosen, and it seems like it's going to be a very packed hall full of different kinds of people wanting to show you stuff. It seems like they've had a really good response to what will be the first full-scale in-person Maker Faire in Rome in a while. And I personally am quite excited about it because I'm going to be there. Electromaker are going to be at Maker Faire Rome this year. If you are someone who watches the show who may also be there, please do let us know beforehand. We'd love to meet you. But yes, in short, there's going to be over 600 projects from all over the globe. People are flying in from quite a number of places to Rome for this particular Maker Faire. And if you would like to know more about that, you can head to this news article. I'll leave a link to it in the description. But yeah, in short, there's no tickets on sale as of yet, but that will be coming very soon. There was one other thing I found kind of interesting too. The news that when they sent it out saying, hey, all of our submissions are in, it's going to be a fantastic show, was with this, which is a story about David Nezumi, who in short is one of 3 people called David on a team that is sending actual tech that they have made into space as part of a SpaceX project. And the link here is that they met at Maker Faire Rome in 2021, and in a very short order have put together a startup that is going to be working with an Indian company that works with SpaceX. The tech that you are seeing here is going to be orbiting the Earth, which I think is kind of amazing. As it mentions in this little write-up here, the goals of the project are still unclear, but it seems to be testing communications infrastructure, which if you think about SpaceX, makes sense. There's a link out to Delta Space Leonis from this article, which is their company, their startup, which is, as it says, it's an aerospace company, but I love these little pocket cubes. I haven't actually really dived into this yet. I'm looking forward to doing so. But yeah, I just thought that was quite an interesting aside. There's a link to this news article in the description of the video. Up next, we have a pocket computer. A pocket computer based on the Raspberry Pi Pico, and this project is kind of special in that it is a bit of a 3-in-1. So, as it says here, Pi Computer, or Pico Computer, or Pico Computer. Pi Computer. It's a universal pocket computer. It is based on the Raspberry Pi Pico, and it also has a retro gaming emulator on there and a long-range communicator. It can do various things in one. In fact, this is one of various iterations of the same circuit board, but it's all made by the same guy, Bobricius. And there's a video version of it here, which shows off a slightly different form factor, which we'll get to in a minute. But what you're seeing here is the Pi Computer ZX edition, which is based on the ZX Spectrum. But essentially, this same hardware can do various things. It is a Raspberry Pi Pico with a LoRa module attached to it, a little screen, and a keyboard. There's a lot you can do with that. So the version we're looking at here is slightly different. This is obviously a little bit more based on retro gaming. It has a nice little retro game pad there. Although, if I remember correctly, doesn't the one up here also have it? It does, I see. So I'm assuming this is just a later iteration in the circuit board design. By the way, while the user name here is Bobricius and is also the name on the circuit board, this is a video from Peter Misenko. And if you want to find this video, you can go to the link in the description. This entire tutorial is linked there. I lost the word tutorial for a second. Although it's more of an explainer, really. It does give you all of the things that you will need in order to make your own. One of the things I particularly liked about this is that it gives you options. These are different boards that could work. So almost everything could be switched out for something else if you're having trouble finding one specific thing, because essentially, as it says, yeah, it's a bright IPS display, it uses a lithium battery, and it uses various just generic things, buttons, switches. There's a lot of different microcontrollers out there with the RP2040 chip on it now. It's just a really nicely put together project. So yes, if you're looking for something that combines retro gaming with long-range communication and a way to just generally mess with the RP2040 chip in a way that doesn't involve always plugging it in and out of computers, this is certainly worth a look. Everything you need to know about it is in the project, which I will link in the description. Just quickly before we move on, I wanted to mention that the Eurocircuits PCB design contest proposal phase is now over. That means that the people who gave us proposals for PCBs that they thought might be cool to make, out of all of those, the judges have picked the ones that are now going to receive their €500 voucher and will be getting those PCBs produced by Eurocircuits. Those people now already have their vouchers. Congratulations to everyone who got their PCBs accepted. I'm really excited to see what you guys come up with. I also wanted to take a second to say thank you to Keith Ravenberg and Francesco Volpe, our expert judges who have already put quite a lot of time in looking through all of these proposals and choosing the ones that would go forward to be made. It's an amazing amount of work to do this, and they are both specialists in their fields. If either of you are watching this, thank you so much for the effort and work you've put into this contest already. But yes, as you can see, the timer has been updated. In 31 days, 15 hours, 19 minutes, and 30 seconds as I film this, these projects will be submitted, and an overall winner will be chosen. It's a very exciting contest for me because while there's been a lot of contests in the time that I've been here, all using different kinds of hardware and development kits and things like that, this is the first time that there's really been a contest that just said, go wild, think of anything that can work on a PCB, and then turn it into something that you will now document. I am so excited to see the variation in all of these projects, and I will keep you updated as the contest goes further. Up next, we're going to be looking at a guitar to MIDI implementation. Now, taking anything that is sound and turning it into MIDI has a number of very difficult challenges attached to it. Without getting into the weeds of the fast Fourier transform and all this kind of stuff, essentially you're having to determine what note is this, and then say, okay, here is this MIDI note that works with it in a very, very small amount of time. Now, this is something that you can do on workshop computers and even laptops. I mean, you don't need that much power, but you can't necessarily do it that well on hardware, unless you're this guy. So this is Philip Carson Gislauer. He is the maker of Midgik, which is a plugin for PCs, for Ableton, for various different DAWs, which turns guitar into MIDI. The difference is he's implemented this on embedded hardware, on a Raspberry Pi Pico, which is an amazing achievement. Again, as I said before, there are various ways you can do this with hardware, but the level of overhead you have is very slim because you just don't have the same amount of processing power as you do with desktop computers. If you'd like to know more about this project, head to the link in the description of this video, which links to this video, because it's a fantastic walkthrough. This is the general overview. As he mentions, there's an op-amp here that goes into the Pi Pico. It's just using a normal ADC pin on the Pi Pico, by the way, doing it via DMA. And then there's the port of libmidgik, which unfortunately is not out at this stage. From reading the comments of the video, it appears that Philip is trying to come up with a way of working out a binary he can release for the Pi Pico that can't be used anywhere else. And I understand that because, yeah, this is something that he made to sell on the PC, and so releasing the source code for that is not ideal if it isn't meant to be open source in the first place. But yes, it gives you a lot of details as to how this thing works and walkthrough of how it all came together. It is a very, very interesting watch. And if you would like to have a peek at the source code, you can. Just like I say, unfortunately, the libmidgik header, the version that you need to work with the Pi Pico, is not available here because that is his own property. But you can kind of get a rough idea by peeking through the main file what's happening here. But yes, all the magic stuff is behind closed doors, which is absolutely fine. I'm looking forward to seeing if there is going to be an update to this project. It's the kind of thing I could imagine releasing in a little box would make quite a substantial amount of money from the right kind of people who would be interested in it. But as a general idea for a project and a wonderful use for the Pi Pico, I found it a surprisingly thrifty way to get working pitch to MIDI going in, yeah, a very small amount of hardware. Moving on to the LattePanda 3 Delta. Now, this is a x86 SBC. We're not going to talk about it too much today. That's because, well, I wrote a news article about it when it was released just the other day. But yes, I got one. I got one through the mail, and I'm very, very excited to play with it. But I don't really want to go into much detail on the show about it until I've had the chance to, play with it, write a review of it, see what it can do. But in short, if you are interested in it, just very quickly, let's fire through some of the specs here, because it has an Intel Celeron N5105. That's one of the newer ones. From what I understand, I haven't had hands-on experience with old and new AB. There's a big performance jump with the CPU there. It comes with 8 gigs of RAM. It comes with a 64GB eMMC drive soldered onto the board, but it also has an M2 slot, so you can put an NVMe SSD drive. Did I get that right? NVMe? I'm very bad at these things. As people who've been watching the show for a long time will remember, I'd call them FGPAs. FPGAs. Oh. Wait, okay, no. Reverse, back to the matter at hand. Very powerful little computer. The thing about these boards that I love, and there's a few x86 boards that do this, Udo have a board that do this too, is that this has an 80 mega 32U4 chip on it. That's the same chip you find in the Leonardo and the Pro Micro, which means that this is set up for physical computing. It's just straight out of the box. It's an x86 processor that works with physical computing. It's really quite amazing. However, we're not going to spend any longer on it today. I'm going to come back to this when I've had it out the box, had a fiddle with it, and we'll talk about it in more detail on a future show. What you are watching is sped up footage of a breadboard sequencer that works via MIDI with a Raspberry Pi. This is a project from Nisa, who's a musician, but also someone who is making their very first DIY electronics project. That's right, this is the first thing that they have made, which is really quite impressive. Now, if you'd like to hear what this sounds like, then I suggest you follow the link in the description. The link takes you to the Electromaker website just here. I would love to play the piece of music that is at the end of this video. I simply don't have the time, unfortunately. However, at the end of the video, it shows a demonstration of the sequencer working with some guitar and some keyboard and some bass drop-ins as well. It's definitely worth checking out. The video itself is just a descriptor of how this thing is all working and how it fits together. And of course, there is the write-up here as well. But a Raspberry Pi-based MIDI sequencer controller, you can do a lot of that on the Pi through software, and if you can connect to it via USB, there's various things you can do to control it. But this is kind of amazing because it takes that idea of using the Raspberry Pi as a controller for MIDI. Many people use them as part of their hardware setup, connecting everything via MIDI and clocking them through a Raspberry Pi. It takes that and it takes it out of the box, as it were, and puts it onto the breadboard. This thing works hand in hand with the Pi. The sequencer on the Pi does not work by itself, and the breadboard stuff does not work by itself as well. They work together, and it's a fantastic first project. It's astounding, really. We are returning to the Brick Experiments channel after a long gap of not covering them on the show, but they're not always Electromaker appropriate, really. If you're not familiar with the Brick Experiment channel, they are a wildly popular Lego-based YouTube channel. They got quite famous for using plastic Lego to bend and break steel, just using some basic physics and some very clever building. But they've also been working on Lego-powered subs for quite a while. And a Lego-powered submarine is something that I love the idea of, but this is getting really quite technically accurate now. It's really clever the way that they've done it. But the first thing to cover that I think is just a fantastic idea that's been in this design for a while is the way that the propellers attach to the hull. So the project uses magnetic bonding, which allows them to have the motor and all of the electronics on the inside of a completely sealed container and attached to the propellers on the outside without there needing to be any holes made in the box. Now, that doesn't mean that there aren't holes in the box, but they are just for the ballast. And we're going to look at how that ballast works in just a moment. But yes, this is what makes it more Electromaker appropriate, I suppose. There's a Raspberry Pi 02W here, along with all of the motor controllers and everything else that's attached to it. It does a buoyancy sensing via a pressure sensor, and as you can see here, there's a little radio in this toy submarine that they're going to take out and attach to the box. Put into the box of their submarine. And when we get onto the tests, you can see just how well this thing does work. And it is really quite a wonderful thing to watch. You can see that the pressure sensor is sensing the depth, and that syringe is moving backwards and forwards, pushing water in or out in order to get the buoyancy to a certain level. And they're using a PID controller, which, as you can see, is pretty accurate, actually. It does pretty well. However, the real benefit of using a Raspberry Pi Zero is, of course, the fact that you can attach a camera to it. So what you essentially have here is a fully operational Lego underwater drone that you can get this amazing footage. And this is a 200-meter journey down a local river to the Brick Experiment channel. Yeah, the fourth iteration of this is so impressive in so many ways. I will leave a link to it in the description of this video. And as if this video wasn't enough, for those of you that are really into the technical side of things and would like to know more, there is a wonderful write-up on the Brick Experiment channel website here, taking you through various different parts. It's broken up into all these different things: the PID controller here, the pressure sensor here, the syringe ballast here, everything you would need to either make something the same as this or to take the ideas from it and make your own project out of it. It's just a wonderful, wonderful project, and I'm so happy to see that it's still going. If you are enjoying the Electromaker Show, consider subscribing to the Electromaker YouTube channel. This will mean that we will show up in your subscriptions panel whenever you come to YouTube. However, if you click this little bell here and you select all, you will also get a notification whenever we put a new video up. If you look under the bell here, you will see this is the notification from this very video from the last show that we put out. Also, on every show that you watch, asking for likes is something that I know all YouTubers do, and it's very annoying, but it makes a difference. It means that you're, of course, showing us that you like the show, but more importantly, that you're showing YouTube that you like the show, and they're more likely to then show it to other people. However, by far the best way you can support the show is by shopping at the Electromaker store. At electromaker.io, we have a shop with over 10,000 products in it. We stock stuff from pretty much everybody, and our Trustpilot score is excellent. We also offer pretty fast shipping as well. And if you aren't familiar with the Electromaker website, maybe you've only come across this as a YouTube show, there's a lot of things on the website you might be interested in as well. As well as buying things from the shop, you can put your projects up online in our community projects section. And in fact, every single month we have a panel of judges that will pick 3 projects that they like from this section and give them prizes. First prize being a $50 Amazon gift voucher and some Nordic semiconductor prototyping gear. Second and third prize being some pretty handy swag, including a USB BLE development dongle. As well as that, we also have the blog where I write news posts and embedded posts and all that kind of stuff from time to time, along with a few other things like featured platforms for everything that you might want to find out about your favorite thing. If you like working with, for example, RT Thread, the open source real-time operating system, we have a platform for them, and you can look at various projects using them, along with blogs and videos and all that stuff. So thank you for the support you're showing us, whether that's buying stuff in the shop or just liking things on YouTube, and thank you for your patience while I do this sort of self-referential advert for the show that you are already watching. So let's get back to it, shall we? Now, a couple of shows ago, we started a contest for this. Now, this is the NRF5340 audio development kit from Nordic Semiconductor. It is a wonderfully powerful little bit of kit because essentially it combines all of the fantastic Bluetooth Low Energy stuff that the 5340 chip, the NRF5340, can give you, with, as you can see, onboard battery connector and battery charger, and an audio codec along with a micro SD port and a bunch of other things. There's a lot of stuff that you could do with this, but I mean, for someone like me, the obvious idea would be, yes, I mean, I want to do something to do with sound synthesis or sampling or whatever, and we're now going to be announcing the winner of this contest. I promise that I haven't just been playing with it all this time. It has been sitting in a box waiting to be given away. I just took it away, just took it out of the box to show you right now. I promise I would love to get one of these myself one day to have a proper fiddle with, but time is never of the essence. However, for everyone that entered the contest, thank you for your ideas. There are some wonderful ones out there. Our judges did pick one very simple but very nice idea for it, so let's find out the winner. And the winner is John Anderson, with an idea which seems simple on the surface but has such a wonderful depth of complexity to it when you really think about it. The feature that interests me is the ability to apply DSP effects to incoming I2S audio streams, then synchronously broadcast them to multiple Bluetooth receivers. Yes, that is a mind-blowingly wonderful idea. Take an I2S audio stream in, apply various different DSP effects to it, because this is a pretty powerful little onboard chip, and you can do quite a lot with hardware DSP, and then you could send them out to different Bluetooth speakers in different points in the room. You could make quadraphonic or octaphonic audio, all with subtly different effects on them. It's a wonderful idea, John, and when you do make this, I really want you to put this on the Electromaker website, document it, make a video of it, partially because, it's great when people put projects on the Electromaker website, but mostly because I really want to see this thing in action. So, congratulations, John. We'll be in touch with you as to how we can get this thing out to you. To everyone else who entered this contest, thank you so much. There will be a lot more specialist contests coming up. We have a whole host of amazing things to give away. And of course, we still have the mystery box contest of that fantastic mystery stuff that Mauser sends me to give out to people. That could be absolutely anything. At one point, there was an electric charging device. No, what do you call those things? A variable power adapter, which is probably worth about $2. So I put an extra teensy in there because that's not a very good prize. But yeah, they can be terrible prizes. They can be great prizes. This is a astonishing prize, and I'm really, really glad we got to give it away. I hope you have a lot of fun with this, John. It's time for that part of the show we called Funding Website Things, where we look at things on funding websites. We're going to start by returning to something we looked at before, which was the Pixel Pump. Now, a quick refresher in case you don't remember what this is. The Pixel Pump is a completely open source, open hardware, 3D printable pump for working with SMD components. The idea is that it has a foot pedal that you can use to take to take components off of the tape and put them onto PCBs if you are doing small scale hand-built stuff. There is quite a niche market for this stuff, really. That's not to say that there aren't products out there for people who hand make PCBs, but they tend to be really quite expensive. This is completely open source, completely open hardware, uses the RP2040 chip from Raspberry Pi, and seems to be just a fantastic project in and of itself. But the reason we're coming back to it is because they've reached their funding goal. They've raised $57,000 out of the $32,000 they were going for, and so the funding hasn't ended quite yet. But this thing is going to get made. If you would like to get one, you can. You can still do it as part of the funding campaign, online. I'm certain they'll be selling them after the fact as well. And $449 is a price which is interestingly been seen as too high by some people and incredibly cheap by others. And I would imagine that the people who are saying it's cheap are the ones who have actually used the industrial methods that exist already and know how much that costs. And the people that are saying it's too expensive probably don't have that much experience with making PCBs. Maybe. I don't want to speak out of turn in case that is wrong. If you think it is wildly expensive and have a good reason to do so, please let me know in the comments section. But the other reason that this is great is that just recently the Teardown Sessions, which is Crowd Supply's podcast with Helen Lee, had Robin Reiter on as a guest. And it's an hour-long conversation as to how this thing came together, various considerations about it, with lots of questions from the audience. And I will leave a link to both the Crowd Supply and this Teardown session in the link of our video, so you can go and take a look at that. It is a fantastic podcast that I listened to. I haven't actually watched it as of yet. Robin's a really fascinating guy. Helen is a fantastic interviewer. I'd really suggest going and taking a look at that. But for now, if the Pixel Pump is something that interests you, head to their page, take a good look at it. There's a bunch of lovely little quality of life features in here that I think make it just a really well thought out bit of equipment. Not least the fact that the pump itself has a very clever filter on it, and the filter is very easy to take out and clean. It is a reusable filter, so you're not going to be sucking bits of solder up into the fan assembly. And also, just simple button will reverse the polarity of the blowing, and it will blow through the tube. So if you have anything stuck in the tube, you can blow it out. If you really feel like you can blow your components around on the desk, probably not the wisest idea if you'd like to keep them though. We're moving on now to the HiPo, which is a small open source e-paper display that's updated and powered wirelessly by NFC. And that last part is really quite special. So e-ink displays have a property that pretty much no other display that you get with Arduinos or Raspberry Pis have, and that is that once the image is on the screen, it can remain there almost permanently without any power. So this makes it perfect for this kind of application. You can derive a small amount of power from NFC. Those of you who've been watching the show for a long time might remember I featured a project which had a badge for a worker entering an office or whatever, and the lights would flash whenever it was near the reader. It had various, possible ideas like, you could use it to light up a dark corridor. It was a bit of a proof of concept, really. But this is that concept being used for a practical reason. And of course, while I was talking to the camera, the example of this actually happening was happening in the background, which you've probably already seen. And there is also, as it mentions here, an STM32 companion board that you can get with it for programming it. Although it does mention that there's a lot of different compatibility options. So for example, Arduino, ESP8266, ESP32, and RPI. Presumably that's Raspberry Pi and Raspberry Pi Pico, given that it's just it's a SPI connection. Although the code that they have is only, open source code is for the STM32 only because they have their board that goes with it. So the NFC reader and the e-paper itself is only $39 with free US shipping and then $12 worldwide, which makes it something that isn't all that expensive if it's something you wanted to play with. I will leave a link to this in the description of the video. You can watch the video here of them working with their built STM32 board, and of course you can dig through all of the source code to see if it's something that you would want to use yourself. One of the things that I couldn't work out precisely from this is whether there's going to be any way of easily working your own app into it. So they will have an NFC phone app that you can use to update it. Whether you would be able to write your own app or use another NFC device to connect to it instead of having to connect to another board like an STM32 or something to it, I do not know. If that's something that's on this page and I'm just silly and I've missed it, please let me know in the comments of this video. But yeah, this is a really interesting way of working with e-paper that I am very interested and excited to try out myself. And yeah, I may have one of these on the way to me to have a little play with, and so when it comes, we'll probably look at this again, because I love e-ink. I really like e-ink displays, and this is a novel way of working with them. We're going to close out this week's show talking about the Nvidia Jetson Orin, which is their new supercomputer SBC for edge AI stuff. And we're also going to talk about a very nice Wi-Fi hack for 3D printers, which is way cheaper than Octoprint, especially if you're buying a Raspberry Pi now in the here and now. But first, this is something that I was really happy to see show up in my recommendations. This is a video from The Factory, but this is part of Core Electronics, who I believe are a quite large supplier of things in Australia for, the same kind of maker and embedded stuff, as far as I understand. However, this is talking about device drivers with the Raspberry Pi Pico PIO. Now, long-time watchers of the show know that I'm a little bit obsessed with the Raspberry Pi Pico at the minute. I've just written a tutorial on the C and C++ SDK. I still work with MicroPython and my other Pico as well, and this is a perfect example of why you would want to use PIO if you are a MicroPython programmer. Because this is working with a load cell, and it does not have the correct the Pi Pico does not have the correct interfaces to work with the load cell as it is. And the reason for this is because the part has a very specific timing that the Pi Pico just cannot sustain with its normal peripheral interface, that is. However, the PIOs on the Pi Pico can be configured to work as pretty much anything and at a very high speed. And this is showing how you can use PIO assembly within Python programs to get things from the load cell and work through the ADC at a high speed. The thing I love about this video is that it explains everything in a very easy to understand way. If you've ever looked at a datasheet and wondered what the timing diagrams mean, this is going to explain it to you in a very good way. This is also showing the typical, a typical application using it. But it also goes through the basics of PIO assembly, which is something I'm learning at the minute too, along with just how you would go about working with and debugging something like this. So yeah, I'll leave it at that. It's a great little video. If you have not dipped your toe into PIO as of yet, it might be a nice place to start. And the Core Electronics YouTube channel appears to be full of videos like this. I had never heard of it before I got recommended this one particular video, but I'm looking forward to having a dig through because it looks like there's a lot of very easy to understand and relatively beginner to intermediate projects you could work on based on these videos. And of course, these guys do manufacture and sell these add-ons. So if you are in Australia or in Asia, I presume, wherever they ship to, it's certainly worth taking a quick look at the Core Electronics site. But yeah, I'll leave a link to this video in the description. You can find everything from there. We're going to move on to Node, which is from a company from Cyberpunk. Now, I'd never heard of this before. It just kind of fell into my lap this week, and I thought it was a little bit too cool to not appear in the show. Essentially, this is a little Wi-Fi development board with an ESP32 on it, which is designed specifically to take any 3D printer within reason and give it Wi-Fi capabilities for very cheap. So it says less than $30. It's actually something like $29.80 or something like that. But what it is, yeah, essentially, it's just a little ESP32 development board with a shim here for the SD card, so it replaces the SD card in your printer, and a little USB cable for plugging into the printer as well, so it can just take over from it. It comes with a browser-based app, and it just seems like a very cheap way of doing similar things to like what Octoprint does, for example. Even I suppose the Spaghetti Detective, although of course that's way more complicated, that uses AI and cameras to make sure your print isn't going to fail and all that kind of stuff. But essentially these are things that hand off control of your 3D prints to other pieces of hardware rather than the onboard hardware of the printer, and this is doing exactly that. So I'll leave a link to this in the description of the video. A couple of small points before I head on. It doesn't come with a case, but you can 3D print your own. In fact, they give you designs to 3D print the case, which would kind of be a cool first project to do with it anyway, if you think about it. 3D printing a case for the new control unit. And the app isn't an app. It's a browser-based app, which means that you can connect to it from anything. It doesn't have to be a phone. This little screen you see somewhere here shows the IP address of this. So you give it all of the details for your Wi-Fi. It will connect to your Wi-Fi network, and then you can just type that into any browser. And if you look here, this looks like an app, but this is actually the phone browser that you're seeing there. So you could control it from any computer, anywhere in the house. It's just a really nice and seems like a very simple and utilitarian way to add Wi-Fi to any 3D printer without having to go through all the bells and whistles of setting things up in a different way. I'm sure that there are other solutions to this, and I know you could roll your own. If you are someone who's a bit more versed in 3D printing than I am, someone who's owned a lot of 3D printers but never really got too deep into it, strangely enough, please do let me know in the comments whether this is unique or whether this is just yet another version of something you've seen a million times before. I thought it was quite a handy little thing. Finally, on this week's show, the Nvidia Jetson Orin. Now, we did talk about this briefly while we were at Embedded World. Those of you who follow the channel may have seen the interview I did with a representative who was working with Nvidia, and they also made baseboards for the Jetson Orin. At the time, the only thing that was available was the developer version of the Orin, and there wasn't actually any modules that you could use in a thing. Now, if you aren't familiar with the Jetson Orin, the Jetson Nano is a board that a lot of people are familiar with. That's their lower level, but still very powerful single single board computer for working with Edge AI and things like that. After that came the Jetson Xavier, in various form factors, and the Orin is the really high one. And it shows in the price as well. So this is the one that Nvidia now have available. I saw this originally on Hackaday. There's a link straight out to the Nvidia site if you want to read what they have to say about it too. In short, the mid version of the Orin is the one that's coming out. There's going to be a 64 gigs of RAM version of it. This is the 32 gigs of RAM version, and it is a module. It's the one you can see in the top left corner of the image here. If I make this slightly bigger, you can see it better. This article actually, as many of the writers on Hackaday seem to do, said exactly what I was thinking just after I thought it, which is like, that's really cool. I'm really glad that they're putting out this super powerful one, but it's a bit annoying for me because what I'd love is one of the little system on modules that fit into the baseboard, because I'm not sure, but I think it will fit with the Nvidia baseboard I already have here. If you know about this and you happen to have it wrong, please do let me know. Also, if you can hear the helicopter, apologies. But I have a feeling that this will actually work with the baseboard I already have. If not, I'm sure it wouldn't be so hard to get a baseboard to fiddle with. I have no reason to get anything as powerful as the Orin. This is, as it says here, the new platform promised to deliver server-class AI performance on a board small enough to install in a robot or IoT device. And that doesn't seem like too much of a stretch, given what I learned about the board when we were at Embedded World. It was doing multiple computer vision tasks in parallel at 30 frames per second. As the guy at the time said, if it was doing that in a headless capacity with a bit more optimization, it could be doing a lot more than it even was. Edge AI is getting a bit crazy. But yes, it is now available. If you'd like to read more about it, I'll link out to this Hackaday article, which gives a really nice roundup of it. But of course, you can jump straight out to the Nvidia site here. And there's also quite a nice little roundup of what the Jetson Nano is, linked out from this page too, if you are not familiar with this line whatsoever. But if you are someone who does use the Nvidia Jetson line and are excited or not excited about the Orin, please do let me know in the comments. I find it quite hard to gauge what the kind of community that watches this show thinks of these products, considering they are right on the line between a very high level, something that tinkerers and makers might buy to learn Edge AI in a very deep fashion, and people who are working in the industry who are just going to get whatever the best thing to hand is at the time. So please do let me know. But anyway, yeah, I will leave a link to the Hackaday link, this Hackaday article in the description of the video. So that has been the Electromaker Show for this week. Thank you so much for joining me. Thank you for putting up with us having a rather sporadic schedule of late. It has been, as I've mentioned before, always been the intention to have this show always be every single week, regular. Sometimes life gets a little bit in the way. As I've mentioned before, I'm a freelancer with 2 children, and depending on the amount of work I have or who is sick or not at the time, which is all of us all the time, it seems, I have issues sometimes getting shows out. I am a one-man production team after all. However, thank you for all of your patience. I've even had the odd person reach out just to say, hey, I hope you're okay when I've missed a couple of shows. That's very lovely of you. It's not necessary, but it does mean a lot to know that there are people out there that care beyond random entertainment that comes out each week. Anyway, that is it for now. I hope you have a fun, safe, and creative week, and I'll see you in the next one.